Welcome to this video, which is designed to recap some of the trigonometry that you should know from Stage 5. This is designed to help you catch up in the Stage 6 Mathematics Standard 2 course, where we'll be looking at non-right-angled trigonometry. So, this video covers something very quick, which is the trigonometry that you've done previously. On the right-hand side here, I have got a right-angled triangle. On the right angled triangle, one of the sides is constantly named something. It's the longest side that's opposite the right angled triangle, and it is always called the hypotenuse. Okay. And Pythagoras' theorem lets us work out the sides if we know one of the other sides as well as the hypotenuse, or work out the hypotenuse if we know both other sides. Trigonometry is more advanced though. It says if we know one of the angles and one of the other sides, we can use it as a tool to work out the lengths of the other sides. So once we include this reference angle here, we can now label the two other sides in the triangle. The side that doesn't meet the marked angle is called the opposite side, and the side that does touch the angle, so I'm just highlighting it here, you can see the angle meets this side, is called the adjacent side. That's that first naming convention that you have to understand. And once we have labeled these sides, we can now pick any two of the sides and form a ratio between them. A ratio in this case means one side divided by the other. So we could have the opposite side divided by the hypotenuse. We could have the adjacent side divided by the hypotenuse, or we could have the opposite divided by the adjacent. So it's not always very useful to say the ratio of the side opposite to the reference angle divided by the hypotenuse, or to say the ratio of the adjacent side to the reference angle divided by the hypotenuse, and so on. So what we come up with, because we're lazy mathematicians, is short, easy names that we can use as a reference for these things. So the first one that we came up with was the sine, spelled S-I-N, and with an E, but just S-I-N on the calculator, the sine of theta. And the sine of an angle is the ratio of the side that's opposite to it divided by the hypotenuse on the triangle. A side that pairs up with that is the cosine of theta. On a calculator though, we're not going to write the whole thing, we're just going to write cos. So cos of theta, which is the adjacent divided by the hypotenuse, and finally the tangent of theta, which we just write as tan of theta. So those are just names that help us write these things nice and quickly, nice and easily. So what I said on the previous slide was what is important to remember about trigonometry is it's a tool. It's a way of finding missing sides or missing angles in right-angled triangles when you've got two bits of information. Those two bits of information are always going to be one of the angles in the triangle and one of the other sides. When we've got that pieces of information, that's enough to determine all the other angles, all the other sides on the triangle, although usually you only have to find one of those things. So it's important when starting these questions to identify what information you've got and what information you need. So here, the 50 centimeters, when we compare it to the reference angle of 40 degrees, we will note that the side does touch the reference angle. It's not the longest side though, so it must be the adjacent side, which I'm just going to shorten to ADJ for adjacent. The other side, the side that we're looking for, it's the side that doesn't touch the reference angle at all, and it's not the longest side, so it is the opposite side. So if we think back to which one of our names, which one of our ratios used the opposite side and the adjacent side, we will hopefully remember that it is the tan of an angle is equal to the opposite over the adjacent. So with any equation, when we know the relationship, we should substitute in the information that we're given in the question. So here the angle, the reference angle, is given as 40 degrees, so it's the tan of 40. It's equal to the opposite side, which we don't know, but we've labelled x, divided by the adjacent side, which we do know is 50 centimetres. So to solve these equations, we go with the technique of balancing both sides by doing the same thing to both. So if I multiply both of these sides by 50, on the right hand side, that will cancel out the divide by 50. So that all we're left with on the right hand side is x. And on the left hand side, I've now got a sum to put in, which is 50 multiplied by tan 40. Like in algebra, we don't write the multiply symbol between the digits of 50 and the word tan, that process. So 50 tan 40 is something that you can just put into your calculator. Make sure that you are in degrees mode. If you're not sure, check with the teacher. And you should find that when you do this, and I'm just going to write what x is equal to because it looks a bit tidier, you will get that it is 41.95 centimetres, accurate to 2 decimal places. This second example is a little bit harder, and it covers something that people often get wrong because they're not sure how to rearrange the equation in this case. So I'm going to start by doing the same things I did for the last one, which is to look at the two sides I've got, determine which ones they are. It's going to help me understand which ratio I want to pick. So the 50 centimetres, it is adjacent to the reference angle of 25 degrees. It does touch, but it's not the longest side in the triangle, because the longest side is the one opposite the right angle. So this one must be the adjacent. Here h is the longest side in the triangle, so it must be the hypotenuse. So then we need to think which ratio involves the adjacent and the hypotenuse, and that is the cosine ratio. So the cosine of an angle is equal to the adjacent side divided by the hypotenuse. Once again, substitute in the information we've got. The cosine of 25 is equal to 50 over h. The process of solving this one is a bit more difficult. Like I said, people tend to make mistakes here. It's important to notice that h is on the bottom of the fraction. We don't want h to be on the bottom of the fraction. That's not very helpful. So what I'm going to do is I'm going to multiply the right hand side by h, which will cancel it being at the bottom there. But because I've done that to the right hand side, I have to do it to the left hand side. So I get h times cos 25 equals 50. So if I were to write that in, it'd be h cos 25 is equal to 50. So once again, I want to make a change that I've just got what h is equal to. Well, this is h multiplied by cos 25. So if I divide both sides by cos 25, that will give me a sum. So on the left, the divide by cos 25 cancels out the times by cos 25, just left with h. 50 divided by cos of 25 is then something I need to put into my calculator. That comes to 55.2 centimetres if we're being accurate to 1 decimal place. And that's how you find those harder sides, where the unknown is on the bottom. So when the unknown's on the bottom, you're going to have to do a division eventually to solve it. But the biggest tip that I could give people, and I say this every year, hopefully some people will listen, is that look at the side, look at the information you're given, and decide, have I ended up with a sensible answer? Right at the start, we determined that h is the hypotenuse. It's the longest side on the triangle. So I've calculated that h is equal to 55. And when I compare it to the other side that I was given, and I'll just mark it again, the 50 centimeters, it is clearly longer. It has to be longer. 55 is bigger than 50 because the hypotenuse is the longest side. If you get to the point where you didn't know how to rearrange it and you tried 50 cos 25, that would come up as 45 centimeters. If you take the time to check, look back at that triangle and think, oh wait, 45 centimeters, I must have done something wrong because it's come out shorter than one of the short sides of the triangle, then great, you know that you've done something wrong. And hopefully, because this is always a division or a multiplication, it should just be enough for you to twig that, okay, I needed to divide there, I didn't need to multiply. So that is my big piece of advice. Go back, look at the question. If it's a hypotenuse, have you found a side that's longer than the others? If not, you've done something wrong. Very helpful for multiple choice questions as well. In a multiple choice question, that usually means you can rule out two answers just straight away like that. So our last technique is finding an angle when you are given two sides. So we've been finding sides before that, but now we're looking to find angles. Here we're given the angle to find. We don't know what it is. We're using the placeholder theta. Here's our right angle. So once again, let's label the two sides. 15 centimeters is clearly the longest side on the triangle. It's opposite the right angle, so that is the hypotenuse. The 8-meter side doesn't touch the reference angle at all, so it must be the opposite. So we need to think which one is that one equal to. Well, the ratio that uses the opposite and the hypotenuse is sine of theta. So the sine of an angle is equal to the opposite side divided by the hypotenuse. Substitute in what we know here. We get that sine of theta is equal to the opposite of 8 divided by 15. Now, understanding the process for what we're doing here is a little bit more complicated, but like I've said previously, the idea when solving equations is you do something to both sides of the equations so that you can just get the variable, the pronumeral, in this case theta, on its own. And we do something to cancel what's already there. So we cancelled a multiplication by doing the division. We cancelled division by doing a multiplication. So we need to think about what is the opposite of sine. What kind of undoes sine? And the answer to that is the inverse of sine, which we write on a calculator and many other places as sine of -1. So what we're going to do, actually that last bit should probably be in red, is we are going to apply the inverse sine on the left hand side, and we are going to apply the inverse sine on the right hand side. On the left hand side, the inverse of sine, the opposite of sine, cancels with regular sine to leave just theta. On the right hand side, this is something you need to put into your calculator in order to work out. If you put the inverse sine, and it usually involves the shift or second function button on your calculator, depending on whether it's Casio or Sharp, you should find that you get 32.23, and it'll keep going on. The next one actually is a 0. It'll keep going on. So in part A, it asks for the answer to 2 decimal places. So the 0 means we don't need to round up the 3. So it's 32.23 degrees to 2 decimal places. In part B, it asks us to use the alternative measure of angles, which is not decimal places, but degrees, minutes, and seconds. On your calculator, you will have a button that either says DMS if it's Sharp, or it looks like a little circle and then a couple of apostrophes if you're using a Casio. Press that button and it will convert it for you. So if we write it out in full, I get 32 degrees, 13 minutes, 51.43 seconds. Our decision on how we round the minutes is governed by the size of the seconds. How many seconds are in a minute? 60. So what's halfway? Well, 30 seconds. So if the number of seconds is 30 or above, then that means we need to round the minutes up. In this case, it's 51, so it is above 30 seconds. So the size of our angle is 32 degrees and 14 minutes. Okay, that concludes the revision section of the non-right angled trigonometry. I hope this video was useful in reminding you some of the basic skills. Do check it back anytime you need to, and of course ask your teachers in class for any extra help that you require.